Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
The year 1750 witnessed a surge of inquiry into the very essence of life itself. Lazzaro Spallanzani, a name now synonymous with groundbreaking contributions to biology, began to unravel the mysteries concealed within the human body's lifeblood. His experiments on the nature of the blood, though deceptively named, represented a pivotal moment in the nascent field of physiology. This work did far more than simply observe blood. It courageously probed its composition, its behavior, and, crucially, its role in the broader context of life processes. The intellectual landscape of this era, however, provided a fascinating backdrop. Preceding Spallanzani, the accepted wisdom concerning the circulation, meticulously laid out by William Harvey in the 17th century, had established a foundation. Harvey's description of the heart as a pump, driving blood through a closed circulatory system, represented a seismic shift. Yet, despite this fundamental understanding, much remained unknown: the nature of blood's components, the mechanisms of coagulation, and, most provocatively, the relationship between blood and the vital force remained shrouded in mystery. This was the intellectual terrain Spallanzani entered. Spallanzani did not merely accept prevailing theories. He was, at his core, an empiricist, a champion of observation and experimentation. His methods, though rudimentary by modern standards, were ingenious for the time. His experiments were not a single, monolithic endeavour, but a series of investigations, each carefully designed to illuminate a specific aspect of blood's properties. One critical element of his work focused on the process of coagulation, or how blood clots. Prior to Spallanzani, the prevailing view leaned toward theories based upon humoral balance, or the body's balance of fluids. Spallanzani, through meticulous observation, demonstrated the role of the blood's physical properties in clotting. He took into account the influence of various factors, the vessel's nature, and exposure to air. He also explored the role of fibrin, though he could not identify it by name. This experimental approach represented a definitive step away from purely speculative investigations of the blood toward a more concrete understanding of its mechanics. The direct applications of Spallanzani's work, at the time of its initial publication, were limited due to the primitive state of medical technology. His impact was felt more profoundly in the realm of scientific thinking. He provided the bedrock for later scientists. It also, however, laid the groundwork for the emerging discipline of hematology. His meticulous observations helped to debunk outdated theories. His work's immediate impact rested on its methodological rigor. Spallanzani's careful experiments provided a template for future researchers to emulate. Each experiment served as a model of disciplined inquiry. He emphasized careful data collection, detailed descriptions, and controlled conditions. These standards, though commonplace today, are evolutionary. Yet later scientific endeavors drew directly from Spallanzani's insights. His focus on coagulation found echoes in subsequent studies of blood clotting disorders. His investigation of blood's response to changing conditions, like the impact of temperature or exposure to air, became foundational for understanding hemostasis, the process of stopping blood loss. His work served as a springboard. It allowed others to conduct further refinements and extensions of his discoveries. The development of microscopy also revolutionized scientists' capacity to study blood. Scientists could investigate blood components, such as cells and plasma, in greater detail. Spallanzani's legacy is especially apparent in this field. Scientists could now observe blood cells and understand the formation and effects of blood clot. The reception to Spallanzani's work, though generally positive among his contemporaries, did encounter certain challenges. The scientific community's acceptance of his findings reflected the era's limitations. Some of Spallanzani's observations were not fully understood. His experiments, however, were lauded for their meticulousness and clarity. He had few detractors, but also few champions who fully grasped the long-term implications of his efforts. The critical revisions to his work came from later scientists. These scientists were able to build upon his foundation. They used more sophisticated tools and techniques to illuminate Spallanzani's initial insights. Further, they provided crucial refinement of the exact mechanisms that Spallanzani had observed. His work, far from being superseded, was incorporated into a more complete picture of blood's functions. Spallanzani received direct influences. He was, in essence, influenced by the work of William Harvey. Harvey's explanation of blood circulation proved critically important. Harvey's rigorous approach helped shape Spallanzani's experimental methodologies. Harvey showed the value of systematic observation. Spallanzani adopted these principles in his own investigations, adding to a legacy of scientific rigor. Further, Spallanzani had learned from the works of scientists like Marcello Malpighi, the inventor of the microscope, Malpighi's observations of capillaries and blood vessels, using a microscope, had provided critical insights into the circulatory system. Spallanzani's influence on subsequent researchers and their work is undeniable. His work informed future physiology research. His emphasis on experimentation and close observation became a hallmark of scientific inquiry. He paved the way for other investigators. These scientists included Jean-Louis Marie Poiseuille and Karl Landsteiner. The advancements in our understanding of blood, therefore, have their roots in Spallanzani's legacy. Poiseuille's work in fluid dynamics, particularly his studies of blood flow in vessels, had its origins in Spallanzani's foundational work. Landsteiner, the discoverer of the blood groups, was influenced by Spallanzani's experimental approach. Landsteiner used Spallanzani's ideas and built upon them, using rigorous methods to advance hematology. Spallanzani's experiments on the nature of the blood stands as a testament to the transformative power of disciplined observation and rigorous experimentation. His work, while firmly rooted in the intellectual context of the 18th century, transcends its time. It serves as a source of inspiration for scientists today. It shows how a deep understanding of this complex substance can improve our knowledge of life. His work continues to inspire and guide us. It reminds us of the critical value of questioning assumptions. His work underscores the essential need for meticulous and disciplined inquiry in the pursuit of scientific knowledge.
We really appreciate you tuning in to this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.